Good morning, everyone. My name is Kerstin Keller, and I want to give you today a project update for eCAL. So I will be talking a bit about the eCAL ecosystem, and specifically, I will be talking about our newest addition to the eCAL ecosystem, which is the eCAL Foxglove Bridge. So, no? Yes? Okay, so I will stand here. This is our eCAL team, and I've been an eCAL team member for almost 8 years now. So I think most of you now know what eCAL is and what eCAL does. For those of you who don't, eCAL is a middleware. It provides pub/sub and client communication patterns, pub/sub over shared memory, UDP or TCP transport, and the client service patterns over TCP. But it's a middleware itself. However, it's not so much use to a specific developer without the tools we have built around eCAL. So when we decided what tools we want to bring to the eCAL ecosystem, we always put the developer first. And we try to think, or in collaboration with the developers, we really saw what is necessary for them. Okay, so one really important point which came clearly pretty quickly is that the developers, they need the necessity, or they have the necessity to record and later on replay data. So this is why we have implemented two tools, eCAL Player and eCAL Recorder, to facilitate this need for the developer. Equally important as equally important as being able to record and replay is the necessity to monitor what's going on in a middleware system. So basically, when you put up a system, let it be in the car or let it be in a still environment, you need to troubleshoot more often than not. And therefore, you want the possibility to see what frequencies are are topics being published in that middleware. Are there any data drops? Is the data getting where it should be getting? So for this, we implemented the eCAL monitor. Yeah, equally as important, also especially when we're talking not about single algorithms, but bigger systems, we want to orchestrate. And for this, we want to start and stop a whole family of tasks. So we also created a tool for this, which is the eCAL. So you saw the picture before. We, the eCAL team, we're a pretty small team. We're 4 people. And the eCAL ecosystem makes eCAL usable. So since we cannot develop all the tools by ourselves, what we often do is try to see what tools are available and how can we integrate them with eCAL. So let's face it, eCAL is a good middleware and it's used heavily inside Continental. But if you're university, if you're a small startup, the chances that you're using a different middleware and the chances that you're actually using the ROS operating system, they're pretty big. So what we've done is we've implemented an RMW, which is a ROS middleware layer, which gives the possibility to stay in the ROS ecosystem and use all the tools and the code that the users are familiar or developers are familiar with, but underneath and under the hood, use the power of the eCAL core communication. So that's also, it's an open source project. However, we are actively looking for a maintainer for that project. Another very big and powerful tool suite is the tool suite provided by MathWorks. So if you're, especially in the domain of developing control systems, you're probably very familiar with the MATLAB Simulink toolbox. So what we have done is we have created an extension to the Simulink toolbox that allows users to use eCAL as a data source and a data sink in Simulink models, and thus integrate their Simulink models very easily with another stack of eCAL applications. Okay. Analyzing one's data, also very important topic. I think every developer knows that they have the need to scan through the thousands of minutes of automated driving data which they collected and analyze what they have. And MATLAB itself, it's a very powerful tool to doing all kinds of data analysis. So what we've done there to extend our ecosystem was to provide the possibility to load eCAL measurements into MATLAB and then give the developers the chance to use all of that power. Okay, the last point for the eCAL ecosystem is the visualization point. And that's really an important topic for me personally. So back in the, let's say, good old days of automotive software development, data was simple. So you had to visualize maybe the wheel ticks you were getting from the sensors, you were visual, or you needed to interpret the speed or the acceleration of the vehicles, and maybe then see what brake pressures are applied in these brake systems. These are scalar data. You were able to read them, you were maybe able to plot them over time, and that was it. But if you think of autonomous systems now, data is more complex. We're talking about camera data, we're talking about radar and LiDAR data, and these data is not easily interpretable by a human unless you can visualize that data. So in the past, also internally, we've taken a lot of time to really have some in-house development for possibilities to visualize data, but we're also looking in the open source world until we found Foxglove. And Foxglove is a visualization tool which is really, really powerful and made specifically with the use case of robotics or autonomous development in mind. So our newest addition to the ecosystem is the eCAL Foxglove bridge, which bridges these two components. And I will talk about this now. Okay. So just to give you a small impression, this is from the Foxglove website. It's a simple Foxglove visualization where you see various camera streams, you see point cloud data, and you see what objects have been recognized. So let's talk about this eCAL Foxglove bridge. How does it work and what is the architecture? So in this wonderful yellow square, think about this as an eCAL system which is communicating. So we have the eCAL monitor running there. On the other hand, we have the Foxglove Studio application. When we first found Foxglove Studio, as it was made for robotics development, it had the possibility to display live ROS data and also to load ROS measurement files. So we were working in conjunction with Foxglove to create another possibility to extend the visualization capabilities for different middleware layers. So what Foxglove developed was basically a pub/sub framework over WebSocket. So you have a client-server connection and publish data then to Foxglove using this specified protocol. Foxglove has published this project and has various language bindings, so you can have TypeScript, Python, C++ application using this transport layer. So we on our end, we have implemented the eCAL Foxglove bridge, which subscribes to data inside the eCAL network and forwards that to the visualization. So let's take a look at how that really works. We have eCAL monitoring, which is the information about all the tasks which are being available in the eCAL ecosystem. We have the eCAL Foxglove bridge, which is doing the bridging between the two worlds, and the Studio Visu. So when there is a new task, the monitoring will inform the eCAL Foxglove bridge that there is a new topic available, and the eCAL Foxglove bridge can forward this information now to the Studio Visu. There, the user can choose to visualize the topic in which the course, the topic is requested. The bridge creates a new subscriber to receive that data and forward it to the visualization. So for this presentation, I have put up a demo where anyone who would start to develop now something in the automotive domain could just start. So as a starting point, we have an eCAL measurement played by the eCAL player, which takes one measurement of the Audi autonomous driving dataset, the A2D2 dataset, which is licensed under the Creative Commons attribution license. What we have also created is a very, very simple object detector where we use the Google Media Pipe framework for this. This basically works. It has a subscriber to subscribe to eCAL subscriber to subscribe to images, and then an eCAL publisher to publish the detected objects. So we have in this demo, we have 2 instances of this running. Oh, no. Anyways, okay, so images, they're being published by the player, they're being processed by the image detector, and then they're sent to the Foxglove bridge. So let's take a look at the video. Yeah, it's playing already. So what you can see is we have 3 instances running. We have the Foxglove visualization on the left side. We have the eCAL player, which is playing the camera images, which are contained inside the measurement. And then we have the eCAL monitor, which also shows here at the moment there are these 2 image detection scripts running. They're just Python scripts, 100 lines of code, nothing special. So they are subscribing to raw images and they are publishing the detections, as you can see in the monitor there. So I'm starting to play the measurement now, and using now the Foxglove Studio Visu to quickly see and visualize the data. So I have added an image panel, and I'm switching now the type of the camera image to display the front left camera. And I'm adding another image panel where I'm switching the topic to display the rear left or the rear camera panel. So what I'm doing now is you can show image annotations, which the detected objects are. And I'm just turning on here the image annotations for the respective channels. So they are just displayed here also on top of this image. So as you can see, it's very, very simple to get started with Foxglove, and it gives the developers the possibility to easily and without programming, without having to worry about the graphic details, to put together a visualization and thus be able to analyze how well their algorithms are performing. Okay. So quick summary. eCAL, it comes with already some powerful tools, and we have tried to make it more powerful by integrating other existing tools. The Foxglove Studio is the newest integration here to our eCAL ecosystem. And now the question to you is, which other tools would you like to see in conjunction with eCAL? So, attributions, and thanks for your, thank you.
There is a question online. So Foxglove is using public data to process visualization and collect data. In this process, capturing cars' number plate and color may lead to a collection of personal identity data without permission. Okay. Is there another way to collect moving object data without breach, or do they process additionally to eliminate confidential information? This is not really a question towards eCAL, but
I'm not sure I quite understand the question.
So it's basically saying
Yok,
that
bu
you are
akşam gelmiyorum ben.
collecting
Siz anne
number,
kıstık
there
bu.
are some private
Arabayı yıkatmaya
information
çıkacağım
being
az sonra.
reported, but I guess so you don't do any post processing in eCAL, and why would you? This is not really a question.
Çok değil sen.
But I do have a question. So there are a lot of synergies, I think, with open eCAL environment that we saw earlier, and that would be a really interesting way of adding the simulation of the sensors somehow. And make the suit much bigger. So if I got it right, you're now not an alternative to ROS, so you can stay in the ROS environment. You have the plug. Did I get it right?
Yes. So if you like, you can plug eCAL underneath of ROS.
Okay.
Yeah.
And still see on the surface the same system.
The communication under the hood is then now eCAL, but all the other mechanisms work with ROS. Okay. So some of the eCAL tools you won't be able to use then if you're just using the communication under ROS, but you get the benefits for the shared memory, transporting UDP, TCP communication.
So maybe we can think about the ROS racer that we saw earlier as a use case. So that
and
could
put
be
eCAL under,
and exactly. So that could be something that we.
Yeah.
Great. Any other question? There is another question. I hope it's not a privacy question. Where is the other question? There is no other question.
Because there was a notification there.
Yeah. So for some reason, my notifications are not loading. Sorry. Okay. Can they identify and visually represent things like potholes and road crossing? This is more a question toward the algorithm that does the.
Yeah, I guess so. The algorithm has to detect what they want to detect, but Foxglove then has some predefined data types which they can display in a 3D scene. So we've seen more now the image view and what you can overlay on images, but you also have the possibility to have a 3D world view where you can plot point cloud data, and you can also plot any kind of lane marker detections in the sort of a list of line strips, for example. And what is also very unique is that you can provide transformations between the different origins of, for example, the sensors. So Foxglove is doing all the maths to plot everything in the right place by itself if you're providing the transformation between the different coordinate systems.
So basically, you have the API and Foxglove does the visualization. You
Basically,
put in principle
the API. You put in data, and Foxglove is doing the visualization for you.
Wonderful. Yeah. Any further questions? Yeah, there's one.
Hi, my name is Funny. I'm from Zetascale. Quick question: how do you differentiate eCAL with other middleware, communication middlewares, in terms of speeds, or what are the advantages of it?
So very good question. So with eCAL, we have the possibility to, depending on what system you are and how your tasks are distributed, to automatically choose the transport which is most efficient for your use case. So for example, if you are on the same system by eCAL, which is very quick, we have very good we've seen really good performance with large images, with large LiDAR data being transferred. And then automatically, when you go to transfer data to another system, then it switches to UDP mode. And so this is one of the advantages for eCAL, but if you want to have a complete list, you can go to our documentation and we list there also the exhaustive list of advantages.